Hello, my name is Eagan Rackley, and this is my presentation from the Malwarebytes 2014 Development Summit, Debugware GUI Testing Awesomeness. So we're basically going to go over some dirty tricks for extending a GUI testing framework using that interfaces with Qt executables. So some presentations do not include things like Mr. T, pimps, thinly veiled use of inappropriate language, or slightly obscure references to Frank Herbert books. This will not be one of them. Okay, so let's talk about GUI testing with images in Python. That's basically what our team is doing right now. They've got some basic Python scripts to interact with the application, but because of the opaque pointers used by Q widgets, they're having trouble getting information out of them, and so they use images. So they scan the application for a certain image, they interact with that image, and they validate the results based on what that image looks like afterward. It's a fine way of doing a lot of testing, but it can be a little brittle, especially if you've got an application where the look and feel is constantly changing. And I think that's something that we can expect from this product over the next few years. If the look and feel changes, they would have to retake all of their images, and it becomes a lot of extra work. So it'd be great if we had something that worked regardless of whether the look and feel of the application changed, as long as those controls are still there. So Qt Developer Days, November 2013, our team gets a presentation, our development team, on Squish. And we love it. It's a fantastic tool. It solves a lot of these problems that we know are going on in QA. We come back from that presentation sort of tried to sell the QA manager on, the elegance of the tool, the data-driven test suite that's available, the effectiveness of using Eclipse as an IDE. We loved it, and we really couldn't convince them to buy it. They just didn't see the cost benefit versus open source tools. So next up, the next thing we did was we started to look for, or personally, this was really a personal journey, I started to look for open source projects that could do this for the team. It's just in my free time out of curiosity. And I really didn't find anything except for Qtest, which required them to know the object name in the code. And because of company policies, that information isn't available to them. Out of frustration and sort of maybe arrogance, I decided that I would write a tool that would do this for the team. It would be fun, it would be interesting, and we had this summit coming up, and we were maybe 3.5 weeks out, and so I thought, I'm going to do this, challenge accepted, and that's what I did. By the way, thinly veiled use of inappropriate language, check. I don't know if you saw it, but it was in the bottom right-hand corner of the last slide. Okay, so one problem is that I wasn't totally sure I could do it, and I just committed to a project with a 3-week time span, and I needed to make sure that it got done. So, holiday vacation, December 2013. Luckily, we got some time off for Christmas, and part of the time I spent was working on this application, and I got to a point probably 1 week out from the summit where I had a debugger class, and I could attach to another process, and I could execute a debug loop and query expressions, etc. That was great. They're totally cool debug loops. You can get information on when DLLs are loaded, when processes are created or exited, when threads are created or exited, trace events. It's totally useful. And what I was focusing on, my master plan was to use debug symbols and expressions to pull that information out of the Qt executable. I knew that I could do it because in autoexp.exp.dat there are some debug expressions that make that information accessible as long as they're written correctly. The problem is that most of the controls in our application did not have expressions for these built already in autoexp, and what I was trying to get data out of was opaque pointers. So I did try very, very hard to extend autoexp, but given the time frame that we had, it was very, very difficult to create effective expressions. And if you look on this slide, you can see what one of those expressions might have needed to look like, and maintaining a list of expressions for the custom controls we wrote or in any of the other controls that didn't already have support was going to take too much time before the performance. So I was crushed. I thought, wow, I've basically been defeated, and I'm going to have to call my boss and tell him that I'm not going to be able to do presentation and do the walk of shame when we go to the summit. The schedules were already printed with my presentation on there, and so I was discouraged. It was late at night, and I was thinking, what can I do that could possibly save this? And I came up with an idea, which is to do something very similar to what a lot of malware authors do, which is to use DLL injection to insert a server that would allow me to get information that I knew was in the executable, which is Q meta object information, which is basically reflection for Qt. It's fantastic. It'll tell you every property associated with a control that's built through their meta object compiling system. So with 1 week to go, I worked like crazy and got that written. And just to assuage anyone's concerns, it does sound a little bit like malware. It's not an attack, but you hear DLL injection attack. So for anyone in the audience, Mr. T's here to set your mind at ease. I explained to him that, this isn't malware, it's debugware. And he sort of says, well, I guess that's okay. And it is. So I'm going to give you a pretty quick demonstration using PimpKitty and PimpDog. PimpKitty can be our client running the testing scripts, and PimpDog can be Malwarebytes or any Qt application. So the first thing PimpKitty does is tell PimpDog, hey, just excuse me, allocate some memory for me. I just need a little string. He's already attached as a debugger to the process, and so he can now basically use certain WinAPI commands to tell him to change his behavior. The next thing it tells him is to write in that memory the name of the DLL that we want him to load that will give us access to all this meta object information. And the third thing you do is you create a remote thread on the target executable, or PimpDog, and it'll basically tell you to load a DLL. It basically gives you the start address of load library, which is a kernel 32 function, I think, and that will cause the target executable, aka PimpDog, to load this DLL into memory. And all of a sudden, that process has a socket server running on it, and you're going to be able to interact with it now over sockets. So look, guys, I know this was really, really a stretch, but worked pimps into the presentation. Check. Okay, so now PimpCat is in charge of PimpDog, or PimpHound, and hey, he has a separate thread running in the process, and it's listening for commands from PimpCat. Now PimpCat only needs to send commands like, hey, give me your list of widgets, give me the properties for these widgets to get control over the data in PimpHound or the target executable and get it back. Another stretch, but slightly obscure reference to Frank Herbert books. Check. So in the last week, I implemented iTestomatic client, which will attach to another process, do what we just saw with PimpHound and PimpKitty, maybe not the most illustrative way to represent this data, and get information out of it. And some stuff that this library and interface can do that Squish can also do is to start and attach to a program, get a list of all the widget names in that program, wait for a widget to appear. Let's say that you're waiting on a dialog to load after you've told your testing script to click on a button. You can just say, hey, wait until this widget is there, and it'll basically block until the injection DLL says, hey, this widget is present. Get widget properties. You can specify a widget name, and it'll give you the full QMeta object contents for that widget, and I'll give you a little more detail on that in just a second. And get next widget name clicked is something I added for this presentation so that when you've got this huge list of all the objects in the application, you can say, hey, give me the next one I click on, and it'll find it in that list and allow you to get the properties. So, demo time. Let's go over to Visual Studio, and I will kick off this process. And please don't hate on my UI. I wrote this in a couple of weekends. So the first thing I'm going to do is, I don't know if that was clear, I'm going to click on File and select and attach to executable. And we'll choose one of our development versions of Malwarebytes and click on Open. And it's going to attach, load the DLL, and then tell it to go ahead and keep running like everything's normal. And what we should see in a second is Malwarebytes pop up. There it is. We've got it in German right now. We'll change the language in a second. But now that we've got it up and running, you can click and view and refresh, and you can get a list of all of the widgets in that application. And for each of those widgets, when you click on one, you can get a list of properties associated with that widget. So for instance, let's say we wanted to see something specific, like let's take a look at detection and protection settings, and we'll look at the heuristic engine. Let's say we want to get the properties for this control. I would click on Get, Widget from Mouse Click, go back over to this Target Executable, click on that guy, and it'll find it. It found it in our list of widgets right here, Check Use Heuristic Engine. So if I double click on that, you can see that it's checked off in the UI. And if you look at the properties, you can see that it is checked. And if we look down here, we can see that there's the text for the control. Okay, so next up, let's say we want to change the language. Let's go back to English, which is the default for Malwarebytes. And we'll look at that control again. We can see that the language has been translated. And if we refresh over here, and we look at the text for that, you can see the language is translated there too. So we're getting that information out of the executable. That's basically how it works. That's the general idea. All of this is, everything in the UI is interacting with library classes that we could theoretically extend PyWin to use. So back to the presentation. So there's some limitations. It's really only useful right now with Qt applications. Just like Squish, you're going to need to compile against the same version of Qt that your executable is using, because Qt behaviors change with each version, and we need to make sure that the same behavior is consistent between both applications. This was written over a couple of holiday weekends, so it's not going to be perfect. And this is a little short slide I added after to sort of tell you how the story ends. We did get a lot of positive feedback from QA. They definitely wanted to integrate this into their testing scripts and use it to make them more easier to extend and make a little more robust and less brittle. And we made some plans to integrate PyWin and the code that I've implemented here. And then right after that, management basically decided that they would purchase Squish after all. So, yay, mission accomplished. This is a much better tool, I think, than what we were shooting for to begin with. But I did think that was slightly ironic and a little bit funny. Management actually said that this presentation helped them understand the problem a little better and allowed them to go ahead and buy Squish. So, the end. This is the address for my GitHub site that has the code for this if you want to take a look at it. Eagan Rackley on GitHub, debug interfacing fun and profit. And that's the end. Thank you for viewing.